Hello everyone, is this working? Yeah, perfect, okay, so perfect. Hello everyone, I'm super glad that this is kind of raw and also nervous, so if I'm not like this, don't worry, it's because of that. So I introduce myself again. I'm Sergio, Alejandro, Fernandez, de Soto, Guerrero, which is a really long name for a really long person. Yeah, that's the level of comedy that we have today. So, as Sam said, we are going to do mathematical magic. So I'm going to start doing magic. Magic with what? Maybe you get spoiled, maybe with cars. Which cars? The cars that I have in my pocket. Yeah. So can you see it there? Perfect, yes. Sorry. Yeah, I moved it. No? Yes? Yep. Perfect. So, because we are in a room full of mathematicians, I have a question for you. Who here intuit that has good intuition? Raise your hand. Do you think that you have good intuition? Yeah. So what's your name? Ian. Right, to the right. You. Yeah. What's your name? Easy. And what's your name? Ian. So Easy and Ian, you are going to help me in this. So the idea is the following. I have here the A's, the 2, the 3, the 4, the 5, the 6, the 7, the 8, the 9, and the 10. I have the cards in order. So what happens if I start to deal cards one by one? I have the A's, then I have the 2. But if I do a switch in these two cards, how it would come? 4 and 3. Then we have the 5, then we have the 6. But if I do a switch in these two, how it would come? 8 and 7, exactly. Then we have the 9, and then we have the 10. So basically, I'm messing the order. So to put back again to the 8 to the 10, I have to do the switch again here, in this position, and do the switch here again, in this position. Let's do this experiment, okay? I'm gonna do one of these switches, but I'm going to do it on my back, so you cannot see when I'm, when I'm doing it, here. But, for example, your intuition does. So the idea is the following. I'm going to deal cards one by one. And when you feel it, you say, switch. Then I will take the next two cards together, switch it, and put it on the table. Maybe you can say switch in the same spot that I did, and put the cards in order. Okay? First with you, and then with you, okay? You. I did one, okay? In these two. Switch here. And the rest of the cards on top. Well, it doesn't matter if I try to mess the order, because your intuition gives us the A's, the 2, the 3, the 4, the 5, the 6, the 7, the 8, the 9, and the 10. It's weird, right? But wait. Because we have two people here. So now you, Sam, and Ian. Easy, sorry. Easy. Now I'm going to do two switches. Again, but I'm doing it on my back. So here, no. Yeah. I did two. So again, I will deal cards one by one. And when you feel it, you can say switch, then I will take the next two cards together, switch it, and put it on the table. Maybe you and you can say switch in the same spot that I did. Maybe. Okay? When you feel it. Good intuition. So here, this is the first one. Another one or no? No? Wait. It was the last one. But it doesn't matter if I try to mess the order, because your intuition gives us the ace, the 2, the 3, the 4, the 5, the 6, the 7, the 8, the 9, and the 10. It's weird, I know. The first one I did it once. The second one I did it twice. So now I'm not gonna say how many switches I'm gonna do, because now your intuition is gonna tell you how many and when. Again, I will do cards one by one. And you can say switch as many times as you want, whenever you feel. Then I will take the next two cards together, switch it, and put it on the table. And maybe you can say switch in the same spot that I did. Switch or no switch? Switch. In this two, switch. Another switch? Another switch? Switch, and the last one. But again, it doesn't matter if I try to mess the order, because your intuition always leads us to have the ace, the 2, the 3, the 4, the 5, the 6, the 7, and all the cards in order. In this moment, the people clap. Thank you, thank you, thank you. Oh, wow. Thank you for that spontaneous clapping. Thank you, thank you, thank you, thank you. I don't like to say that I'm going to do magic tricks. It's more about I'm going to do experiments. So I want to do another experiment. This is what was about intuition. Now I want to do one about precognition. So I have something here. I don't know if you can see it here. Perfect. This is a prediction. Do you know what a prediction is? A prediction is something that will happen or should happen in the future. Let's see. For this, let's take this card here, this card here, this one here, maybe these ones, maybe this too much, like this, and yeah, like this. So the idea is I want to shuffle cards, but I don't want to shuffle cards in a normal way, because for me this is too boring, okay? I want to shuffle cards face up and face down. And because of this, we have new possibilities. So for example, we can deal, turn over, deal, turn over, deal, turn over, deal, turn over, deal, or turn over. So for example, Ren, do you want to deal or turn over? Deal. Deal. You, do you want to deal or turn over? Turn over. You, do you want to deal or turn over? Deal. You, do you want to deal or turn over? You, do you want to deal or turn over? Yeah. Which one? This one or these ones? This one here. And with these ones? Turn over? Do you want to do it one more time or this is enough? So now you are going to take the last decision, the important one. Try to imagine that this is like a book. So a book, you can close it in two different ways. From left to right or right to left. How do you want to do it? Like this or like that? This one. Are you sure? Completely sure? Okay? Right to left. At the beginning, I told you that I have a prediction. Something that will happen or should happen in the future. And that moment, already happened. So I don't know if you can read it here, but I have this here. Can you read it? At the end, there will be 5 face-up cards and 5 face-down cards. So that means that I said, you told me to deal, turn over, deal, turn over, deal, turn over, and how to close it. We end up in this situation, having exactly 1, 2, 3, 4, and 5 face-up cards, and 1, 2, 3, 4, 5 face-down cards. But wait. Because I have something else. Furthermore, the red ones will be separated from the black ones. That means that if all these cards here are black cards, this one here are, or should be, all red cards. Now it's going to be, thank you so much. So now for the next experiment, I will need something that is called a twin card. Let me take this one, let me just do it as fast as I can. These two, for example, I don't know, this one and this one, this ace, this other ace, and let's take the 9 and the other 9. So do you know what a twin card is? So a twin card is a card that has the same color, the same value, but a different suit. So for example, the twin card of the 10 of diamonds is the 10 of hearts. The twin card from the king of clubs is the king of spades. From the 10 of clubs is the 10 of clubs. Sorry, the 10 of spades is the 10 of clubs. From the ace of diamonds is the ace of hearts. From the 9 of clubs is the 9 of spades. Okay? So, I don't know if you have heard about this theory that says that every decision that we take, every decision that we made, is split like the universe like in two, like a parallel universe, like in Marvel movies, like the multiverse. We are going to take decisions. In this, I have 1, 2, 3, 4, 5, and 5. We are going to do merequetengues. What a merequetengue is something, a funny word in Spanish that means we are going to have a top card from the bottom part. So that means, for example, if we have to do one merequetengue, and I don't know, you say that do it on the left, I will take one card from top and then put it on the bottom. Or if we have to do 4 merequetengues and someone says, no, do it on the right. So I will take 1, 2, 3, and 4. That's the idea. The idea is I'm going to mix the cards with you in this way to take the top one, and then we are going to discard them, okay? So, for example, you. Let's do 4. Where do you want to do it? Left or right? Right. Your right or my right? Your right. My right. 1, 2, 3, and 4. And let's discard these 2. For example, Ren. Let's do 3. Left or right? Right. Right again. 1, 2, 3. And discard these 2. Let's do a couple more. Let's do, for example, 5. For example, you. Where do you want to do it? Left or right? Yeah, you. Left. Do you want to do the 5 one here, or do you want to do 3 here, 2 here, 1 and 4?
The first one you suggested.
Sorry?
The first thing you suggested.
The first one that is suggested. Ah, okay, 5 here. Okay, sure. 1, 2, 3, 5. Ooh, let's put.
You missed the 4.
The what?
1, 2, 3, 5.
I missed the 4. Let's see if this will happen. I don't know. Let's try to do the last one. Well, shit happens. I don't know. For example, you. Where do you want to do the last one? In left or right? My left. Are you sure? Yeah. I'm not sure, to be honest. Left. Ay, Dios. Well, at the beginning I told you that we have twinkers, that we are going to take decisions. You decide where to do the merequetengues. I do something that I also supposed to happen, but let's see. We end up having 2 cards. I also told you at the beginning that we have twin cards. Cards that have the same value, the same color, but a different suit. That means that if we end up with this card here, this one is, or should be, the twin card. This will be a coincidence. Magic would be if all the other ones also match. Thank you, thank you, thank you, thank you. Which one do I have there? Aha, I have one that I really like that is related with something that is called a, I don't know how to call it this. When you want to be something that, manifesting. I don't know if you have heard about this, that for example, you want to become rich, you say, I'm rich, you became rich. Or you want to say, no, I want to be famous, you became famous. I'm not really a huge fan of this theory, but I'm changing my mind. I will show you why. So can someone help me in this? Not all of you at the same time, please. Can you please come here? What's your name, sorry?
Greg.
Greg. Can you go an applause from Greg? Can you also bring the table? A chair, yeah. Come here. Here. Okay, so, perfect. Can you shuffle the cards?
You want a riffle or?
As you want.
Doesn't look like a loaded deck of cards.
He knows some things. Okay, perfect. So let's take this to here. Because I realize that you can find a card and make it appear when you name it.
Okay.
It's weird. The important thing is you have to do a magic spell. You have to spell the name. That, again, is weird. I will show you. So, for example, let's take the 10 of hearts, okay? So the idea is, if we name the card can appear. Mm-hmm. Again, it's weird. I will show you. It's 10. I'm really bad on spelling, so can you help me? It's T, N, of, F, hearts. H-E-I-R-T-S, hearts. When you spell magic,
M-A-G-I-C,
you can make it appear. It's weird, I know. Take another card. That one. Show it to the camera? Okay. Which one is it? Okay, it's the king of clubs. Spades, sorry. So, because something that I also realize is it doesn't matter the name. It's just about the intention when you name the card. That's the important part. So, for example, the king, okay? So it's K-I-N-G of spades, right?
Spades, yeah. S-P-A-D-E-S.
Spades. If you spell magic,
M-A-G-I-C,
the card appear. It's weird, I know. So, take another one. This time, don't show it to the camera. Yeah, take it. Don't show it to the camera. Okay, just look at the card, okay? Because, again, it doesn't matter the name of the card. It's about the intention. So, for example, I can spell another card. So, I can spell this one here, the 6 of spades. So, for example, let's take the 3 of diamonds. Or let's take another one. Let's do it random. Like, the 4 of diamonds. This is your card?
No.
No, because your card is here. So, because it doesn't matter. It doesn't matter because my intention is to make your card appear. It doesn't matter if I name another card. The 4.
Okay.
F-O-U-R of O-F diamonds. English or Spanish?
Spanish.
In Spanish, we have 2 ways to say diamantes. We can call it diamantes or rombo.
Okay. Go rombo.
Rombo. R-O-M-B-O. Because it doesn't matter if I name another card. It doesn't matter if it's another language. If I spell magic, M-I-G-I-C, I can manifest it.
Yeah.
What was your card?
The 9 of spades.
And make it appear. Thank you so much. No, don't worry. You can help me in another thing.
Okay.
Yeah. So now this one, thank you so much, Greg. So this one maybe may work, maybe not. This is something that I'm trying now. So let's see. So the idea is, I don't know if you have watched these old Western movies with someone try to put like the ear in the floor to hear something is approaching, like a train or an stampede or these kind of things. I found this interesting to try to do it in magic. Because, for example, magicians can find a car using their hands. Because you can, sleight of hands, blah, 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 weird things that magicians do. Or, for example, the sight, because you can see the car, the reflection of the car in the eyes of the spectator, weird things that magicians do. So I will try to find a card using my ear. Let's see. And because I'm not going to use my hands, can you shuffle the cards? Okay. And put it here. Can you square the deck? Perfect. Okay, so now put it more near to you. Okay, perfect. So now you are going to pick a card. So try to cut around the half and put it against your chest, okay? Okay? So you have a card?
Yep.
Okay, perfect. Put it again there and square the deck. Okay, and take the cards in your hand. And because I told you that I'm going to use my hands near my eyes, I'm not going to see anything. And for sure, I cannot see anything, believe me. So the idea is, if I'm going to find the card using my ear, can you deal, for example, did you play Uno before?
Yep.
Okay, so deal, for example, in 5 piles. But important, face up, okay? Do it. Because the idea is I'm going to get used to the sound when you are dealing, because in some point you are going to see your card. If you see your card, don't hesitate, don't do it slow or faster, because you are going to give me information. I'm going to try to hear that subtlety. Did you already see your card?
I have.
Uh-huh. If you want, you can keep dealing. Don't worry.
Keep going?
If you want, you give me more information. Okay, so now in one of those piles is your card. Can you square the piles?
Yep.
Or do you know what? Do you know in which pile is your card?
Yes.
Okay, so can you please turn over that pile? Okay. Did you turn over?
Just that pile?
Yeah. Okay, and the other one, discard them. Discard them, blah, blah, blah. So now in front of you, you have a pile, okay? A face-down pile.
Yes.
Take it in your hands.
Yes.
Okay, so perfect. So listen to me, Greg. Deal here, one by one, face up, slow and steady, in order that I can hear your card, okay? Stop. Greg, for the first time, what was your card?
The 9 of clubs.
Because with this here, I stop you exactly in the 9 of clubs. Thank you so much. Thank you so much. Now you can go to your seat.
Do you want the chair, sir?
Yeah, please, thank you. So, I told you that you like the magic. Did you like the magic? But with more energy. Do you like the magic? Yes, yes, that's the truth. So now, this is not a spoiler because we're in a colloquium, in a mathematical colloquium. Well, this is related with math. All the tricks that you saw is related, math related. The first one is related with something that is called positors. And the other one is related with other ideas that I have trying to do and work with positors. So, because of that, let me put some slides. Yeah, here. Ba-da-ba-ba-bam. Let me put maybe this here because it's easier for me. Ta-da-pa-pa. So, Positriodal magic, Sergio, Alejandro, Fernandez, Soto, Guerrero, blah, 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 blah. So the thing is, I'm going to show you something that is called a positroid, because this is the main object that I'm using to try to shuffle things in your ways. Because if you saw, the first one is like related with facing, shuffling card face up, face down, blah, 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 and it's related with these kind of things, and objects that are in projection with these positors. Then I'm going to explain the intuition test, that is the first one, the color separation, that is the second one, and the other ones I'm going to also explain, but not with positors, with other things. So the first thing is, what is a positroid and what do we need to define it? Let's keep it easy. The first thing that we need is something that is called a matroid. A matroid is, just think that this is like the generalization of linear independence, okay? That's the idea. So you have a collection of, a ground set that is the numbers from 1 to n, and then you're going to have bases. The bases, they are like subsets of the set 1 to n, but with two conditions. The first one is a non-empty collection, and the second one is the exchange action. What does that mean? When you have two bases, and you take one element from here, you can find another element in another base that you can put it there, and you find another base. That's the idea of linear independence, okay? So, now the thing is, we have something that is called realizable matrix. A realizable matrix is basically, you have a field, you have a matrix over a field K, and you can obtain the information of the basis of the matrix using the linear independence of the columns of the matrix. That's the idea, okay? That's the idea. So, we are going to say that a matrix is representable if realizable over the real numbers. So now with this, we can talk about positroids. So a positroid is a representable matrix such that it's non-negative. What does that mean? So when we have the matrix that represents this matrix, when you take all the maximal minors, all the determinants are always greater or equal to 0. So we have this idea of matrix with this positive condition. So we have a positroid because we have a matrix that is positive, so we have a positroid. Nice. So why do we care about positroids? Because there are a lot of different reasons. Because the people in physics really like this object because they're related with causal algebras, the amplitude-hadron, quantum field, Feynman diagrams, so on and so on and so on. In mathematics, because they have nice combinatorial properties. They were born in this paper here. That is called Totally Positive Mathematical Network by Alexander Podnikov. And there are like a lot of objects that index positroid. There are Young tableaus, feelings of Young tableaus, by Python graph network, the correct permutation, so on and so on and so on. But for us, and for me, because I can do magic with this. And basically the idea is I want to try to find new connection with new objects that also index positroid. And one of those one is called bicolor permutations. So, bicolor permutation are this thing here. So the idea is we are going to have a permutation, okay? But now we are going to put colors in the letters. And the colors is red or blue. In this case, the red is 2 and the blue is 1. But we are going to have a condition. When we have an ascent in the one-line permutation, we have a descent in color. In this case, that means that we are going to have red-blue pattern. Example, I have a pointer thing. Let me see. Okay, so example here. So we have the 4 and the 8, so we have an ascent, so we have red and blue. Then we have the 7, the 6, the 5, the 3, and so on. There are descents, so we can put the colors as we want. In this case, I put it like that just because. There is no any special reason. The only condition is when you have an ascent. So we have a 1, a 12. So we have an ascent here, so we must color red and blue. So then we have the 11, the 10, the 9, and the 2. There is a descent. We color as we want just because, in that way. There is no restriction in these things. But now, this color condition is the key in the tricks. So I have a question for you. Can you guess why the color is the key for the tricks? Think about it. Meanwhile, I'm going to drink some water. Any guess? Any guess is a good guessing. Don't be shy, you can talk. No one? Any idea?
Face up, face down, but only one of the tricks made obvious use of that.
And because of that, you won a chocolate. So maybe if I ask something and you ask, maybe you can win another chocolate. But yeah, that's a good intuition. It's related with these kind of things. So the things that I use in the first trick is basically I use a bicolor permutation of size 10 when the orientations is the color in my definition. So face up is blue and face down is red. So the other thing that I use is I use a nice symmetry on positoids and a bijection between analogous definition of the bicolor permutation, because we can also have this condition instead of having ascents and descending color, we can have it vice versa, like having descents and ascending color. It's just because this is symmetry, just instead of read the permutation from left to right, read it from right to left, is that. And the way you can go from this ascent condition in the definition to the descent condition is that, is just invert the order of the permutation. And the second thing is I use a lot of copies of bicolor permutation of size 2 inside the cards that I'm using as bicolor permutation of size 10. Because this is a nice way you can use bicolor permutation because they have like a nice structure like in blocks. So you can have like, instead of a bigger bicolor permutation, a smaller bicolor permutations. So let's go to the camera. Yes. So, for the first trick, what did I use was, let me take the cards again from the ace to the 10, ace, 2, 6, 7, 5, 9, 10, we have the 3, we have the 7, and I think that we have all the cards, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the idea for me is, in my hands, I have a bicolor permutation in a descent condition. For me, when we have it face up, okay? So in this case, I can color as we want. In this case, I color just everyone face up, just because I can. And because I'm using the smaller positoid that I can do it, I will explain later what does it mean. So the idea is I'm going to use this bijection between the two definitions of bicolor permutation with a descent condition. Try to imagine that my hand is like having an ascent, and on the table is the other way around, okay? So, because I need to invert the order, if I start to deal cards one by one, if I do it face up, I have the ace, I have the 2, I have the 3, I have the 4, tan, 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 tan. When I take it up again, the only thing that I have to do to reverse the order, because before I have it to ace to the 10, is just do this. Now I have the ace on top, the 2 on top, the 3 on top, the 4 on top, and the 5 on top. So, what happens if I do this switch in these two cards, together cards? I have the ace, I have the 2, I have the 3. If I do a switch in these two cards, I'm inverting the order in these two, because the first one is the 5, but if I do this, I just invert in the order. But, let me see again, 4, 5. But again, I have the 4, I have the 5. If I do a switch, but then I change the orientation, you see that I'm messing the order here. So this is not a valid bicolor permutation in my case, because you have to also change the orientation, blah, blah, blah. The idea is you are messing the order, because you are actually not doing the bijection that you have to do. That's the thing. So then you have the 5, the 6, the 7. You do a switch here. You change the orientation. You turn over the cards to change the orientation. You are messing the order here because this is not a valid bicolor permutation in my case, and so on and so on. So I'm messing the order. But what happens if I start to deal cards without changing the orientation? So let me put this for the ace to the 10. See, I have the ace, I have the 2, I have the 3. I do a switch here, I'm changing the orientation here. I'm applying the bijection just locally in these two cards. Here I'm messing the order. But when I put these two cards together, what happened? That's the trick. It's super silly, I love it. So the idea is, again, you are applying locally this bijection because you have a lower card, a bigger card, you change it, you put it together, and this is the bijection, but locally, just 2 by 2. That's the idea. But again, this is super counterintuitive because you know expect that the orientation actually matters when you are inverting the order of the cars. But for me, this is important because you are actually doing the bijection between these two conditions of the definition of bicolor permutations 2 by 2. And if you do it fast, for example, I have the ace to the 10, if you do it like this, like this, like this, like this, and do it again, it looks like I shuffled the cards, right? But it wasn't. That's the idea for the first trick. So, questions for the moment? Any questions? No? No? Okay, so let's go with the next one. So for the next one, the color separation, remember that I told you that I have a prediction, that's something that will happen in the future, blah, 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 blah. So the idea in this case, I use the idea of invariant on a group action where the group is the set of bicolor permutations. But the invariant is not the cars, it's the information that I have in the cars. I will show you. The other thing that I use copies, again, of size 2 in a bicolor permutation of size 10. But now I'm going to encode 2 bicolor permutations at the same time when you have 2 consecutive cars. One is using the actual color of the cars, the red and black, and the other, again, using the orientation. So, the important thing is we define this using the parity of the positions, okay? Because for me now, the first number is an odd number because it's 1, and the second one that is the lower one is the 2 because it's an even number. This is important for me. So, the thing is, we have this. Because of that condition that we have that when 2 cars have same orientation, they have different colors. And when 2 cars have different orientation, they have the same color. So the trick, the thing that we have here is we have this information here. Because we have the parity of the position, we have the orientation, and we have the color. So if we know 2 of this information, we have the third one. So for example, if we know the color and the orientation, we know the parity of the position. If we know the orientation and the parity of the position, then we know the color. And if we know the parity of the position, the color, we know the orientation. So the trick is basically perform shuffles that preserves the previous property. And we are going to use this that is called Kato shuffles. Kato is basically because it means cut and turn over. So the idea is we can cut as many times as we want, and we can turn over an even number of cars. So, well, this is a note because, again, this is important for an even, but we can generalize it using the idea of positive and these kind of things. So, let's go to the camera again. No, so is, yeah, this one here. So, the thing that I have here is having 5 red cars and 5 black ones. So the thing is I'm going to use the bicolor permutation like this. 1 black, 1 red, 1 black, 1 red, black, red, black, and red. So the idea is we perform these Kato shuffles. So for example, we can turn over these 2, we can cut, we can turn over these 4, we can, for example, cut here, we can turn over these 2, we can cut here. We have a mess, okay? But important, we have information about the parity, the position, and the orientation. So if we have 2 cars with same orientation, they have different colors. If you see, these have 2 different colors, they have 2 different colors, they have 2 different colors. But if they have this different orientation, they have the same color. That means that this car here is a black car. I know that this is a black car. So for example, this one here is a red one, because I know these are 2 consecutive cars, they have different orientation, so this one is a red one. This one is a black one, this is a red one. This one is a black one because 2 cars with the same orientation, they have different colors. So we have that this is red, this is black. And because these 2 are together, this one have different orientation, they have the same color, so it's red. And we can perform shuffle like this. So you can cut, you can turn over, you can cut, you can turn over these 2, you can do another different thing that also belongs to the group of this permutation, because you can do, for example, this, and turn over, the thing that I have been doing in the trick. You can take, for example, 2 consecutive cars together, and turn over here. You can do this, you can do this, you can take these two, you can do this, you can you can turn over. And at the end, it doesn't matter because we still have the information of the parity of the position and the cars. So if you see, this one is red, and in this case, this one is black. And because we are using the parity of the position, the only thing that I have to do is split it in two piles, because this is odd, even, odd, even, odd, even, odd, even, odd, even. And you can see it here. Because using this condition of the color permutation, the orientation, and the other things, now we split it in two piles. All the face-up card here, they have the same color, and all the face-up card here have the same color. And the face-down card had the opposite color. So this one is the black one, and this one is the red one. So the only thing that I have to do now is just turn over one of the piles. It doesn't matter which one, because at the end, I'm going to have all the face-up cards being the red. So that's why I have the prediction, no. At the end, there will be 5 face-up cards and 5 face-down cards. But even more, because I also have information about the color. I'm not only splitting the cards by orientation, I'm also splitting the cards by colors. That's why I can also have the colors here. Questions? No? No? Okay, perfect. So, the important part here is that the difficult part is, if you see, well, basically I'm using this idea of shuffling cars like in different ways, these kind of things, but for me it's kind of difficult because you have like a heavy machinery to have these all nice properties, but the difficult part is try to do magic. Because if you saw, the first one is basically just doing a bijection, an inversion locally, and the second one is just doing this shuffle that preserves these properties. But the thing is, I told you that you can generalize this idea, because this second trick that I showed you is something that is called the Homer principle, and it has been described in the 18,000s, so there are like 150 years of history of magic that use these kind of tricks using an even number of cards, but because of the people in magic doesn't know about something more general than permutation, they say, no, when you want to do it with an odd number of cards, it's impossible. But the answer is you can, because for example, in my case, I describe these kind of things using positors. And for me, it doesn't matter the number of positors that you have. It's just a number for me. The only thing that you have to care about is the permutation that you do. But again, it doesn't matter for me because I also know how they work. So you can generalize it, and you can have, for example, the odd Homer principle. And more important, you can also write a book, because I also write a book using all these ideas and all these kind of tricks, and all the tricks that you saw in the presentation that I published myself. But yeah. So because I have 10 more minutes, right? I cannot see over there. 10 more minutes, right? Okay, so if that's the case, so thank you. Any questions? Any questions?
I'll ask one. I was utterly convinced that you had, on every question you asked, a follow-up question to potentially give you one bit of control. Like if I want to have an arbitrary permutation, that gives you sort of one transposition for everything you do. Is that a reasonable avenue to kind of, is there some mathematical way that you could say, okay, I have, this many bits of transpositions and kind of do the trick in that tricky way?
It's because of the bijection that I'm using, because in the case that I'm using, when you do the bijection between the ascent definition of bicolor permutation and descent definitions, you are doing duality in positors. And in my case, because I'm using all the cards in one direction, I'm just using the positor that the bases are just all the numbers, 1 to n, and then the other one that is 1, 2, 3, up to n. So basically, I'm just doing these two. And the idea of using these two is if you want to have something that's called a circuits, again, this is like heavy math there involved. The only thing that you have to do is just take two consecutive cars. So you can do these kind of things. And in my case, it was weird to look at it because I was trying to do example of this bijection by hand, which is longer. So I start to use cars. And I start to changing the colors, like changing the colors of the cars, blah, 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 blah. And then I say, well, I can just tune it over because it's just two properties. And then I start to do this, and then I saw it and say like, well, what is happening here? Because I'm doing the thing, and I say, okay, I know that this is supposed to be happening, but when you show it and you see the cars, it's like, what? So yeah. Again, so it's because you have these kind of things, you have three consecutive cars, it's only that just that thing, and yeah. So I hope that you answered your question. Okay.
Are there other questions?
I mean, like, what is it about positroids that makes them the target for, like, card tricks? I mean...
Because I work with positroids.
I see. Okay, but, like...
Because of that. But actually, I have been thinking about it because I started to do it working with positroid because at the beginning, in my master, I was thinking, I want to shuffle things in weird ways. Like, for example, what happens if you want to shuffle dices instead of cards? What happens if you want to shuffle these kind of things? Then I started to work with my advisor. Then we tuned over to try to work with positroids because there are like this definition of bicolor permutation, these kind of things. And then I realized that you can have like nice properties there because this is not completely more general, like for example, sign permutation, because sign permutation is like the same, but you don't have this condition in the colors because sign permutation is you have a permutation, you have two colors in each color, in each letter, but there are a lot of different things that you can do with there. But because I'm more used to use bicolor permutation in this kind of sense and the bijection and all these kind of things, and I was using the cards and these kind of things, I said, maybe I can try to use these ideas to do magic. It's just everything concise. That's the answer, basically. But you can do more general things.
Very surprising.
Yeah, thanks.
Other questions? All right, let's thank Sergio.